Today, we're diving into the world of iterators and iterables. You've seen for loops before, but have you ever stopped to wonder what's going on under the hood? How do loops actually work? Well, it all comes down to iterators and iterables. An iterable is basically any object you can loop over with a for loop. Lists, tuples, strings, sets, you name it. These are like containers full of data. But an iterator? That's an object that knows how to walk through that container, one item at a time. It doesn't care what's at the finish line. It just knows how to get to the next step. Let's take a look under the hood at how this loop works. First, it calls iter on my list to get an iterator. Then it repeatedly calls next on that iterator until eventually a stop iteration exception is raised. That exception lets the loop know it's done. We can actually do this manually to illustrate how the for loop works. First, we take my list, which is an iterable, and we call iter on it. This returns an iterator for us to use. Now we call next a few times on that iterator, printing the result each time. Eventually, when there aren't any items left, we get a stop iteration exception. Here in our case, we would need to manually handle the exception, but fortunately loops in Python handle these exceptions gracefully without us needing to worry about them. Okay, so we've seen how to create and use an iterator, but let's take a moment to define what an iterator actually is. An iterator is an object that lets you step through a sequence of items one at a time, like a stream of values. But there are two very specific things that make something an iterator in Python. First, it must have a next method that knows how to get the next item from an iterable. Second, it must have an iter method that returns the iterator itself. That second part might sound a bit circular. I'll explain why in just a bit. To make this more concrete, let's look at a very simple custom iterator. We'll create a class called count_to_3. Inside it, we define the init method and set current to 1, which is where our counter will start from. Then we add a next method. If our counter is less than or equal to 3, we increment it internally before returning the current value. Otherwise, we raise a stop iteration exception. Lastly, we define the iter method and just return self. And that's it. We've just created a custom iterator from scratch. Just like a built-in Python iterator, we can use our custom version in a loop or manually by calling next. First, let's take a look at using it in a loop. When we create an instance of count_to_3 and pass it into a for loop, Python knows how to handle it. It keeps calling next until the stop iteration exception tells it to stop. Or we can use it manually by calling next to get the same result, one value at a time. This is the essence of what makes something an iterator. It remembers where it left off, it knows how to get the next value, and it knows when it's out of items. And because we wrote iter to return itself, it can be used directly in loops that expect an iterable. We'll dig into that idea more shortly. Let's clear up something that often causes confusion when people first start working with iteration in Python. An iterable is not an iterator. An iterable is any object that can return an iterator. That's it. If an object has an iter method, it's iterable. Lists, strings, sets, dictionaries, even files, they're all iterable. You can use them in a for loop because they can hand over an iterator when needed. But they're not iterators themselves. Why? Because they don't have a next method. Let's see this in action. We'll take a list called myList and try to call next on it. That raises a type error. Python is trying to tell us, hey, this object doesn't know how to get the next item. Now let's pass that same list to iter. This creates an iterator. Now we've got something which has both an iter and a next method, so we can start calling next on it. This pattern of using iter on an iterable to get an iterator is exactly what Python does under the hood whenever we use a loop. Also worth noting, iterators themselves must return self from iter. That might seem odd, but it's so Python can treat them like an iterable, which is necessary to make things like loops work seamlessly. So in short, iterables have an iter method, but no next method. Iterators, on the other hand, have both methods. Let's talk about something that catches people off guard with iterators. Once you move past an item in an iterator, it's gone. You can't go back. No rewinding, no index-based jumping around. Let me show you what I mean. Here we created an iterator from a list like we did before, and then called next until a stop iteration was raised. But now, if we try to call next again, Python continues to raise a stop iteration, no matter how many times we try it. You see, once you reach the end of the iterator, that's it. There's no going back. And unlike lists, we can't use indexing to refer to a specific item. Trying that will simply raise a type error. So here's the takeaway. Iterables like lists are reusable. You can loop over them multiple times, and you can use indexing to refer to specific items. Iterators are one and done. Once you've gone through them, they're spent. If you need to go through the values again, you'll need to recreate the iterator from the original iterable. This behavior is actually really helpful when you're working with large data streams, like reading from a file, querying a database, or processing an infinite sequence. You don't want all the data sitting in memory at once, you just want the next item when you need it. Iterators are extremely memory efficient. Let's say you need to process 1,000,000 numbers. If you store all 1,000,000 in a list, that's 1,000,000 numbers loaded into memory, just sitting there. But an iterator, it doesn't need to store everything. It only gives you one item at a time and only when you ask for it. That's what we mean by lazy evaluation. This function is a generator, which, like an iterator, only produces values when requested. I've linked a video and blog post below which goes into detail on generators. But for now, just know that a generator is a type of iterator, and we can use it just like we would a normal iterator. Even though we're counting to 1,000,000, we haven't actually created a list of 1,000,000 numbers. We've only generated the first two, and memory-wise, that's a huge win. This is why iterators are so useful for dealing with big or streaming data. Imagine reading lines from a massive file. You don't want to load the whole file into RAM. You want to read one line at a time, process it, then move on. This kind of on-demand processing is what makes iterators so powerful. If this video helped you out, give it a like, subscribe for more Python tips, and check the links below for the full blog post which covers iterators and iterables in more detail.